Hello and welcome back to Mr. Lamb's Science Corner. We have three new demonstrations for you today. Most very simple. Materials that you should have around the house. You may have to do a little bit of purchase for one of them, but in essence it's very simple. And the first one is going to be a rubber band demonstrating a concept called entropy. Okay, so there's the word. And entropy is a function of, if I can get this out here, the second law of thermodynamics. And thermodynamics, quite frankly, is extremely complicated. You probably don't want to get into a big discussion with your students about it. But if you're interested, Wikipedia has a nice article on rubber elasticity. In rubber elasticity, they talk about all kinds of things that you probably won't want to talk to your students about again, but you might want to read about it for yourself. The interesting thing about the second law of thermodynamics is that it has been used to prove, so-called, that evolution can't exist. Because entropy, basically, the second law of thermodynamics says that entropy always increases. And entropy is a measure of the randomness of a system. And they say that if it always increases the randomness of the system, then that proves that you can't go from simple to more complex. Which is a complete misunderstanding of the second law of thermodynamics, because it basically specifies it has to be within a closed system. And the only closed system we know of is the entire universe. And so the randomness, the disorder of the system is increasing quite a bit, because our sun is putting out 3 million tons of material every second. And that just kind of scatters out into the universe. And so when you have that much randomness occurring, you can have systems within make some changes. A good example of this would be you can take a bunch of pennies that are just here, there, and everywhere, and you can stack them all heads up in a nice little column. That column is a lot less random than scattered pennies everywhere, but you had to put some work into the system. Okay, so anyway, so all that means that if you have a rubber band, and this rubber band is one that I happen to have handy here, but if you want, you would probably want, let me see if I can get here. I like to write things down so that it helps you if you want to look for it. Number 64 rubber bands, if you go to Staples, and again, remember I mention names for places where you could go, and I'm not getting any advertising from these people. But number 64 rubber bands are nice and thick. They're about 1/4 inch, or in width, I should say. And I don't know how long they are like this, but they make a nice rubber band for what we're going to do. And what we're going to do is we're going to take the rubber band, and then you want to lick your lips to get them nice and moist, and then stretch the rubber band quickly and feel that the rubber band's a little bit warmer. Now hold it for a while and let it get back to the temperature in the air around. And then, I'm kind of hurrying this a little bit, lick your lips again, and then let it go back, and it will feel markedly cooler. Now, my experience has been that when you stretch it out, it will be warmer, but it's hard to tell. It really is, at least to me. I don't know, maybe it's just me, but it's a little hard for me to tell the heat. But if you let it sit for a while and then let it go back and touch, it feels quite a bit cooler. And I'm not really sure why it doesn't feel terribly warm, but it feels a lot cooler. That's beyond me, but it's a fun thing to do. And the reason I give you number 64 rubber bands is that it's easy for the kids to work with. Makes a nice difference. And you're going to need to buy a bunch of rubber bands. And Staples has the bags of, I think it's a quarter pound or something like this, and there's probably several hundred rubber bands in there. And in terms of chemical safety and such, after you're through with them, you're going to want to get the rubber bands back so they don't shoot them at each other the rest of the day. And then you're probably going to want to put them in a little bit of bleach water or something like this so you can use them again. So anyway, that is the first demonstration. Rubber bands. Okay, the second one is really complicated. Not. A gallon plastic bag, some water, and you're going to pour the water into the plastic bag. And you probably want to pour more into it than that, but this will certainly work. Now, you have a plastic bag full of water. What on earth could you possibly do with a plastic bag full of water other than throw it at somebody? Here's what you do. You take a sharp pencil and you poke it right through. And then you take another sharp pencil, and notice I'm twisting here so that it goes through a little bit better. And then if you have more pencils, and make sure they're sharp, you can poke this look like a porcupine. And if you want to, you can take a twister tie and you can twist it off. And then I don't really have a place to do that here, but you can then hang this. And quite frankly, I did this a few times at school, and I hung it up, and I finally took it down after a couple of months. It can sit there for that long, and it just doesn't leak. Now, what does this prove? It probably proves that polyethylene, the plastic in the bag, is different than the latex for a rubber balloon, because we know if we take a balloon and try to put a pencil through it, we're going to pop it. And you're going to have a big mess. So, kind of a fun thing to do. Let's see if I can set this here. Aha. And then the third demo is more fun with carbon dioxide. And if we remember, carbon dioxide was created by taking some baking soda and putting it here in the bowl, and then some vinegar. But before I do that, I'm going to take a little candle that they usually use this for either a votive candle will work very well, a little stub of a regular candle works, and this is, I think, for heating chafing dishes and such. And I happen to have a bunch of these at home, so that. Okay, so what I've got here is I have a burning candle in a coffee cup that looks like a beaker. And I'm going to take some baking soda, put it in the bowl here, and then I'm going to create some carbon dioxide by pouring vinegar in, just like we did before. Going to get a whole big bunch here, and then I'm going to take a coffee cup, which is empty, and I'm going to scoop up, and notice I'm not touching the liquid there. And then I will pour this into the coffee cup, and the carbon dioxide flowed from the coffee cup into the coffee cup. And notice that the candle went out because carbon dioxide does not support combustion. Excuse me. So there's two things you can do in fun with carbon dioxide. You can float bubbles on here, and I know the bubble didn't show up too terribly well, but try it. You'll enjoy see what it is. And then have here. The trick is to get lots of good carbon dioxide building up here. Okay, so use more baking soda and vinegar than you think you're going to need. Because one thing that you're not going to see is that I tried it a couple of times and it worked well in rehearsal, and then the first 3 times I tried it, it didn't work well until my able wife said something about, let's try more carbon dioxide, and so I did, and you saw it go out. So understand that sometimes demos don't work, and which is always embarrassing, but the kids always love it. Okay, so and then if you can try to get it to work, and it may be just to say, kids, I don't know what's going wrong. We'll try it again tomorrow, and then after school you practice, and try different things until you get it to work, and then you say, the next day you say, kids, I think I got it to work, and then you do it and it works well, and they're all very happy. You know, kids are easily amused, and watching the teachers sweat bullets because it's not working is okay sometimes. So don't be afraid to do demos thinking you might fail. Always try them ahead of time. Never do a demonstration for the first time in front of kids. You need to practice several times to get it down so it works, hopefully, but also for the safety considerations. That, you know, if something goes very, very wrong, you don't want it to go wrong in front of students. I remember one time I was doing a demo with sodium and water, and sodium, which I don't have here, explodes on contact with water. So I had a beaker like this, and I had water, and I put the sodium in, and I put a screen on top of it. And the first time I did it, it worked beautifully. It worked just great. And then we went to lunch, and a new class came in. I said, class, watch this. And I put it in there, and just as I was almost ready to get the screen on, it blew up big. And the little tracer of sodium went out and was heading towards a student, and fortunately wound up a foot or two short. But I was sweating bullets as that sodium was going there because it was going to cause a really bad burn. And what happened is that when I poured the water out of the tap, it's cold, and so that slows down the reaction. But over lunchtime, the water warmed up, and so the reaction went that much faster and that much more dangerous. So always try to do things, you know, beforehand, preferably with someone there who you know, you go like, hey George, come on over here, and I want to show you this, and you bring in another teacher, and they do the same for you too. Anyway, so those are the demonstrations for today. Thank you very much.